Hello, ninth graders! This is Sir Jonathan Campilla, your virtual math teacher for this week. Our topic for the week focuses on solving equations transformable to quadratic equation. This lesson is anchored on the most essential learning competency, solves equations transformable to quadratic equations, including rational algebraic equations. In solving equations transformable to quadratic equation, we have to remember the following. First, simplify the given expression. In case that the equation is rational, multiply both sides of the equation by the least common multiple of all denominators. Second, write the resulting expression in standard form. Ax squared plus bx plus c is equal to 0. Third, solve the resulting equation using any of the four methods, such as extracting the square roots, factoring, completing the square, or using the quadratic formula. And last, check whether the obtained values make the given equation true. Now, let me guide you to answer activity 1 entitled I am a transformer. In this activity, we will just transform each of the following equations into quadratic equation in the form ax squared plus bx plus c is equal to 0. Let's have the following examples. We have x times the quantity x plus 2 is equal to 9. In this case, we will use the distributive property of multiplication over addition. X times x, x squared. X times 2 is 2x. That is equal to 9. Then, we transform this equation in standard form. Ax squared plus bx plus c is equal to 0. And that is x squared plus 2x minus 9 is equal to 0. As simple as that. Next example. We have the quantity x minus 1 squared plus the quantity x plus 3 squared is equal to 2. First, we expand this equation as quantity x minus 1 times the quantity x minus 1 plus quantity x plus 3 times quantity x plus 3 is equal to 2. By FOIL method, we have x times x is x squared. X times negative 1 is negative x. Negative 1 times x, negative x. And negative 1 times negative 1, positive 1. Plus x times x, we have x squared. X times 3, 3x. 3 times x, that is 3x. And 3 times 3 is positive 9. That is equal to 2. Next, we combine like terms. X squared plus x squared, we have 2x squared. Negative x minus x plus 3x plus 3x. We have positive 4x. Positive 1 plus 9 is positive 10. That is equal to 2. Then we have to transform this equation in standard form. Ax squared plus bx plus c is equal to 0. And this is equal to 2x squared plus 4x plus 8 is equal to 0. Next example. 5 over x plus 1 plus 3 over x minus 5 is equal to 3. In this case, we need to multiply the whole equation first by the least common multiple of the denominator, or simply the least common denominator or LCD. The LCD of this equation is x plus 1 times the quantity x minus 5. Then, each term inside the grouping symbol should be multiplied to the LCD. We have 5 over x plus 1 times the quantity x plus 1 times the quantity x minus 5 is equal to 5 times x minus 5. Next, 3 over x minus 5 times the quantity x plus 1 times the quantity x minus 5. That is 3 times the quantity x plus 1. Next, we have 3 times the quantity x plus 1 times the quantity x minus 5 is equal to 3 times x plus 1 times the quantity x minus 5. Next, we simplify. By distributive property, we have 5 times x is 5x. 5 times negative 5 is negative 25. 3 times x, we have positive 3x. 3 times 1, we have 3. That is equal to 3 times the equation using the FOIL method. X times x is x squared. X times negative 5 is negative 5x. 1 times x is positive x. And 1 times negative 5 is negative 5. Combining like terms, we have 5x plus 3x is 8x. Negative 25 plus 3 is negative 22. That is equal to 3 times the quantity x squared minus 4x minus 5. Simplifying further, we have 8x minus 22 is equal to 3 times x squared is 3x squared. 3 times negative 4x is negative 12x. 3 times negative 5 is negative 15. Transforming this equation in a standard form, ax squared plus bx plus c, we have 3x squared minus 12x minus 8x minus 15 plus 22 is equal to 0. Simplifying, we have 3x squared minus 20x plus 7 is equal to 0. Ngayon naman, ay gagabayan ko kayo kung paano sagutin ang Activity 2 entitled True Value. In this activity, we are going to determine the roots of the following equations transformable to quadratic equation. Let's have the following examples. X times the quantity x plus 2 is equal to 3. By distributive property, x times x is x squared. X times 2 is 2x. That is equal to 3. Next is to transform this equation in the form ax squared plus bx plus c is equal to 0. That is x squared plus 2x minus 3 is equal to 0. Then, we will now solve for the value of x. By factoring, we have the quantity x plus 3 times the quantity x minus 1 is equal to 0. Using the zero product property, x plus 3 is equal to 0 and x minus 1 is equal to 0. We now have x sub 1 is equal to negative 3 and x sub 2 is equal to 1. Next is to check. Our equation is x times the quantity x plus 2 is equal to 3. When x is equal to negative 3, we have negative 3 times the quantity negative 3 plus 2 is equal to 3. Simplifying, negative 3 times negative 3 plus 2 is negative 1. That is equal to 3. Negative 3 times negative 1 is positive 3. That is equal to 3. the left side is equal to the right side of the equation. When x is equal to 1, we have 1 times the quantity 1 plus 2 is equal to 3. 1 times 1 plus 2 is 3. That is equal to 3. 1 times 3 is 3, which is also equal to 3. The left side is again equal to the right side. Therefore, the values of x are -3 and 1. Next example. The square of the quantity x plus 1 plus the square of the quantity x plus 2 is equal to 1. We expand this equation as the quantity x plus 1 times the quantity x plus 1 plus the quantity x plus 2 times the quantity x plus 2, that is equal to 1. By FOIL method, x times x is x squared. X times 1 is x. 1 times x, we have x. 1 times 1 is positive 1. Plus, x times x, we have x squared. X times 2 is 2x. 2 times x, we have 2x. And 2 times 2, we have 4. That is equal to 1. Combining like terms, we have 2x squared plus 6x plus 5 is equal to 1. Transforming this equation in standard form, we have 2x squared plus 6x plus 4 is equal to 0. This equation can be reduced to x squared plus 3x plus 2 is equal to 0 by dividing the whole equation by 2. From the reduced equation, let's find the value of x. By factoring, we have quantity x plus 2 times the quantity x plus 1 is equal to 0. By zero product property, x plus 2 is equal to 0 and x plus 1 is equal to 0. The first value of x is equal to -2 and the second value of x is -1. Let's check the values from our equation. We have the original equation. The square of the quantity x plus 1 plus the square of the quantity x plus 2 is equal to 1. When x is equal to -2, we have the square of the quantity -2 plus 1 plus the square of the quantity -2 plus 2 is equal to 1. We have the square of -1 plus the square of 0 is equal to 1. 1 is equal to 1. The left side is equal to the right side of the equation. When x is equal to -1, the square of -1 plus 1 plus the square of -1 plus 2 is equal to 1. We have the square of 0 plus the square of 1 is equal to 1. 1 is equal to 1. Again, the left side of the equation is equal to the right side of the equation. Therefore, the values of x are -2 and -1. Next example. 6 over x plus x minus 3 all over 4 is equal to 2. First, we need to multiply the LCD to the whole equation. That is 4x. Then, each term inside the grouping symbol should be multiplied to the LCD. 6 over x times 4x is 24. X minus 3 all over 4 times 4x is x times the quantity x minus 3. That is equal to 2 times 4x. That is 8x. By distributive property, we have 24 plus x squared minus 3x is equal to 8x. Transforming the equation in standard form, we have x squared minus 11x plus 24 is equal to 0. By factoring, we have the factors quantity x minus 3 times the quantity x minus 8 is equal to 0. By zero product property, x minus 3 is equal to 0 and x minus 8 is equal to 0. The first value of x is 3 and the second value of x is 8. By checking, we have the original equation 6 over x plus x minus 3 all over 4 is equal to 2. When x is equal to 3, we have 6 over 3 plus 3 minus 3 all over 4 is equal to 2. Simplifying, 6 over 3 is 2. 3 minus 3 is 0 divided by 4, we have 0 is equal to 2. 2 plus 0, we have 2 that is equal to 2. Left side of the equation is now equal to the right side of the equation. When x is equal to 8, we have 6 over 8 plus 8 minus 3 all over 4 is equal to 2. 6 over 8 is the same as 3/4. 8 minus 3 all over 4 is 5/4. That is equal to 2. Simplifying, adding similar fraction, we add the numerator. 3 plus 5 is 8. Then we copy the denominator, which is 4. 8 over 4, we have 2, which is also equal to 2. The left side of the equation is equal to the right side of the equation. Therefore, we can say that the values of x are 3 and 8. That's all for this video. Thank you for watching and stay tuned for the next virtual instruction.